So section 8.3 is really a, excuse me, a continuation of what we were doing yesterday, where we're going to actually just put everything together. So yesterday we talked a little bit about how do we interpret a confidence interval. Okay. We talked about what's needed to be able to do a confidence interval, and we actually talked about calculating out the z-scores. So we're going to put it all together in a four-step process. So when we actually construct a confidence interval today, we're going to concentrate on today's lesson on proportions. Remember that P represents a population proportion. So all of these problems that we do today will deal with proportions and trying to actually capture that true population proportion. We're going to use a sample today. So you'll see down here the formula. You're going to use a sample proportion. Again, remember P hat means sample proportion. We're going to use some sample that we went out and collected and create the confidence interval by going plus or minus our z star. Remember that z star is determined by that confidence interval level. So whether it's like 90%, 95%, 99%, they all have different z star scores. So yesterday we were using inverse norm to help us find some of those. Now, the last part is the standard deviation. Okay. And it's the standard deviation for a proportion, which is P1 minus P over N. But notice in this formula, we're not using P, the population proportion, because we don't know it. You actually have to use P hat in place of P, since that's the statistic you will actually have. So, four-step process. Okay. So when we do these problems, we'll make sure that we cover these four things. State, plan, do, conclude. We've been doing those for quite some time now. So with the state, what I like to tell students is to make sure, okay, your state is just a simple sentence. I gotta give you a fill in the blank sentence to do. We want to find a blank percent. So this is your confidence interval level. 90%, 95, 99%. Confidence interval for the true population, our parameter. Today we're doing proportions. When we come back from break, we're going to be doing means of context of the problem. Okay, so what does that proportion actually represent? So you're just looking at the problem and sometimes just writing word for word a phrase right out of the actual text of the problem, hence context. Then, once you write that sentence, we have a plan. What are we going to do? So, first thing you want to do is state what we're trying to find, or specifically, what type of interval are we going to use? Because there are technically a bunch of intervals. We're showing you the very first one. So on all of our problems, we will say one sample confidence interval for a population proportion. Again, when we get back from break, we'll say one sample confidence interval for mean. There's actually two sample ones also, but we're not going to cover those here this year. Okay. So then we talked about our conditions. Remember, it has to be random to factor out bias. It has to be normal because we're using z-scores based off a normal curve. It has to be independent. So in order to use that standard deviation, got to show the population is greater than 10 times the sample. Once you demonstrate all those, you get a do the do. Yeah.
So wait, is the n, right, and independent supposed to be an s?
This?
No, the other one.
This?
Yeah, that one.
Yeah, they're both ends. This is population.
Yeah, so.
This is sample.
Okay, you said 10 times the sample.
Yeah, 10 times the sample. Population must be greater than 10 times the sample.
But then it's an s now, that's all. It's just s usually.
Capital N represents population, lowercase n represents sample.
Okay.
Alright, so now, in the do, this is where we get to do the numbers. So all you're doing is calculating out the formula, or calculating out your interval. So at the very end, you'll actually do the plus minus, and you'll get two numbers. So then at the very end, we'll conclude. We'll have a nice conclusion, and we give you a nice sentence. We gave you this sentence at the beginning of class yesterday. We are blank % confident that the interval from blank to blank captures the true proportion, in this case, of whatever the context of the problem that we're trying to find. So, we're going to take you through we're going to do a couple examples today, showing the step-by-step way. You guys will get this down, hopefully very well, and you'll find that this process is actually not too hard. Alright, so let's flip to our next problem. And you will think today, with my examples that I picked, we're in health class. Yes, we have some interesting topics today. So it says the Gallup Youth Survey asked a random sample of 439 U.S. teens aged 13 to 17 whether they thought young people should wait to have sex until marriage. Of the sample, 246 said yes. Construct and interpret a 95% confidence interval for the proportion of all teens who say yes if asked this question. So, we start with the state. So I'm basically going to fill in the blank statement under state in the four-step process, which goes like this. I was doing the last part. We want to find I look here, 95% confidence interval, and you can abbreviate confidence interval CI, for the true proportion of U.S. teens that say one should wait to have sex until marriage. Marriage. Marriage is what brings us together today. Do you have no way to love man and wife? What a great movie. So if you don't know what movie I'm talking about, sometime over break, watch The Princess Bride. It is such a wonderful movie.
Yes, you person listening to.
REOS? REOS is rooms of unusual size. Alright, so now we got the state done. Wrote our one sentence. Our plan. The plan actually takes the longest because we got all those fun things to do. So we will construct a one sample confidence interval for a population proportion, for P. So now I get to do all those steps. I got 3 things to check. Is it random? We have a simple random sample of, I believe it was 439 teens.
That's correct.
So in this case, yes, check. So it was collected where we had a random sample, so that factors out a lot of bias. Good. So, is it normal? Well, in order for it to be considered approximately normal, the question becomes is n times p hat greater than or equal to 10, and n times 1 minus p hat greater than or equal to 10. We have to use p hat because we don't have p. Now, if you think about what these numbers represent, n times p is the number of successes. So basically, you can think about this number right here as how many people said yes, or our yeses. And this number here would be our no's. So, according to our survey, how many teens said yes?
246.
Yeah, 246 said yes. That's greater than or equal to 10. So let's see, we had 439 total. 246 said yes. So 439 minus 246. 193 said no. So both conditions are met. It is approximately normal. How is my speed right now? I feel like I'm going a little fast.
You're good.
Okay.
We did this yesterday, I think.
Yeah. Independent.
That's a good Rudolph and Rudolph's name.
Had a very shiny nose. I was singing that to my daughter last night, in fact.
Is that what we have?
Well, she wanted a story on her back, so I was telling a story of Rudolph, and so I kind of sang the song. Hey! So, alright, now with independence, okay, we are sampling without replacement. So we need to check. So check, is the population greater than or equal to 10 times our sample? So in our case, is our population greater than or equal to 10 times our sample was 439? So is our population greater than or equal to 4,390?
I hope so.
Well, what's our population?
USD.
US teens. So we would definitely say yes. There are at least 4,390 US teens. Oh yes. There's that many teens probably in the metro area. Probably just in the Lake Conference we have that many. Suppose if we're talking 13 to 17-year-olds, almost in the school district. So are all our conditions met? Yeah, so now we get to do the do. So step 2 by far is the longest. Step 3, do. So I want to calculate out my confidence interval. So here's the formula I'm using.
Is there a way we can do that on the calculator?
You can plug in the numbers.
Well, yeah.
Wait, how do you know if there's more than 4,000?
Because we're talking United States.
Oh.
That's why. So, now I gotta get these values. What's p hat?
Population. No.
No.
46.
Sample proportion, which is... How many said yes?
46.
246 divided by... Okay, so take a second and let's calculate that out.
0.56.
Okay, I believe you are correct. It's like 0.56 and actually 0 if I were to actually go out 3 decimal places. Sorry, just letting the calculator warm up here. What's our n?
439.
439. So I got all these values, but I still need to get one more.
Z star.
What is z star equal to?
Z-score.
Yeah, it's a z-score. So what size of interval am I finding? 95. I'm looking at 95, so that leaves 2.5. So I'm just going back to what I was doing yesterday. Some of you, and I would suggest on some of these, you're going to see certain confidence intervals pop up over and over again. You'll start to memorize what these are. So if you actually go inverse norm of 0.025, that will give you 1.960. It'll give you the negative. But we also know the positive is on the other side. Just to show you. Clear this. Large screen. Second vars. Inverse norm. 0.025. Close my parenthesis. Look at that. Negative 1.9599 is 960. So now, I'm going to plug it in and start calculating out my interval. How's my speed? Okay.
You got 1.960 from your inverse norm.
Inverse norm of 0.025. So, I'm going to plug it in. Sample proportion. Alright, that's 0.560. Plus or minus, my z-score was 1.960.
Wait, why isn't it negative 1.9?
It's both. Plus
Oh, plus or minus. Okay.
or minus. Alright? So, the p-value was 0.560. Now, I tend not to write 1 minus 0.560. I think to myself, what would I have to add to 0.560 to make 1? 0.44, right? Or 0.440. So these two numbers should always add up to 1. Because this is the probability of success, probability of failure. Over, our case, 439. So I'm going to get 0.560 plus or minus. Now I'm going to calculate out this whole margin of error. So take the calculator, slide it over here, so that you can see how I'm getting my calculation. So I do everything inside the square root first. 0.56 times 0.44 divided by 439.
Are you supposed to add it up first, then divide?
Yeah,
Or
no, you
so it's multiply, like multiply it all, then divide it by 439?
Well, what I did multiply these two
Yeah,
together.
and then enter, then divide it by 439?
Yeah, because
It'll still give you the same answer.
Really, because when we did it for z-score, we get a wrong answer.
Really? 0.56 times 0.44.
Enter.
Enter.
Now
Div-
divide it.
Divided by 439. Same answer.
Wait.
Yeah,
Yeah, okay. I thought I was going to do that.
Okay? Well, order of operations, yes, when you do z-scores, you're doing subtraction and addition before you divide. But with multiplication in PEMDAS is at the exact same time.
Alright.
Okay? So, when you're doing like the z-score, you're actually telling do the subtraction up top and then divide it. You take the whole top and then divide it by the bottom. So your calculator is going to do these two first,
So it's
and
just
then
only
divide it.
addition and subtraction.
Yep, then it's the PEMDAS issue. So now I need to take the square root of this answer. So now that's just the square root part. So it still needs to be multiplied by 1.96. So this becomes my margin of error. So my margin of error is within 0.046.
So it would be plus or minus 0.046.
Exactly. So you can think about this is 56% of students believe they should wait until marriage before having sex. But the margin of error of that statistic is off by 4.6%. So if I add and subtract that value, I have a lower bound of 0.514 and an upper bound of 0.606. So again, what I'm doing is going 0.56 plus 0.046. That's this value, 0.606. 0.560 minus 0.046. I'm just doing it in my head. Is that it? This is my interval. I'm done with the do.
Yes.
Now all we have to do is conclude. Okay. So again, I'm just going to write that sentence and fill in the blanks. So the sentence starts off by saying, we are blank percent confident. Well, we are 95% confident that the interval from blank to blank, from 0.514 to 0.606 captures the true proportion of U.S. teens who say one should wait until marriage to have sex. Alright, so what I'd like you to do is flip over to the next problem, and we're going to do this one together, but we're going to do it in steps. Meaning I'd like you to do the first step, and then we'll check it. We'll do the second step, or have you do the second step. We'll check it. Third and fourth. Alex.
So what are we supposed to do with the 0.56 times 0.44? We're supposed to just do it all at the same time?
Yeah, it's 0.56 times 0.44 divided by 439. I hit enter on my calculator. Then I did square root of answer. So I got that part. And then I multiplied it by 1.96. That's where that 0.046 is coming from. Okay? Alright, so let's go to the next page. Since we're still on this fun topic of sex, I guess, nice health topic. So, here's number 2. And this is always fun for me to do because all I have to watch is watch and see what you guys do when I read this question. According to an article in San Gabriel Valley Tribune, most people are kissing the right way. That is, according to the study, the majority of couples tilt their heads to the right when kissing. Now, some of you are thinking right now, you're going, to the right or to the left? In the study, A researcher observed a random sample of 124 couples kissing in various public places and found that 83 out of 124, or 66.9% of the couples, tilted to the right. Construct and interpret a 99% confidence interval for the proportion of all couples who tilt their heads to the right when kissing. Alright, so go ahead right now, and I just want you to do the state. I'm going to pause this.
I think this is like, shoot.
As you're finishing up your sentence, hopefully it's something close to this type of statement. Okay? I wrote, we want to find a 99% confidence interval. So you should be saying 99% confidence interval for the true proportion, or if you said for the population proportion, that's fine, of couples who tilt their heads to the right when kissing. Just had to make that sound. I know, that was kind of creepy, wasn't it?
The person who's listening is probably gonna.
Let's see if that got recorded. I'm sure it did. Alright, are we okay with the state? I'm okay, you're okay? Let's go to the plan. So I'm going to give you a couple minutes to work on the plan. So I'm going to pause the video again here. Alright, so let's take a look at least step 2. I know some of you are already doing step 3 and step 4, which is great. Okay? But I just want to make sure your step 2 is basically matching what we have, or what is needed for this step. So again, we state what we're finding, or what we're going to construct. One sample confidence interval for a population proportion. So we go through random, normal, independent. We're told we do have a random sample of 124 couples, okay, in various places that was taken. Is it normal? So basically, how many couples were kissing tilting their head to the right versus tilting their head to the left? So we had 83 that said yes, 41 that said no. The 41 is coming from 80 or 124 subtract 83. Because if 83 said yes, the rest had to say no. So both of these conditions are met. Then with the independents, since you're sampling without replacement, just check to see if the population is greater than or equal to 10. 10 times 124 is 1,020 or 1,240. It's probably safe to assume that, say if we're in New York doing this, or even in Minneapolis, we could definitely run into over 1,240 couples in various places possibly kissing. I won't make the kissing sound again. Very tempted. A little too creepy, huh?
Very. Do it.
Is it like the same thing as nails going down a chalkboard?
One step above.
Alright.
I've been stopped.
Nicole!
How many people have been waiting to do the do? Alright, I'll give you a minute or two. Go ahead, those doing the video, do the. Alright, so let me unpause it for the do part. So again, just like when we're doing the actual interval, doing the calculation, I always like to state my formula, and then I like to state the variables so I know what numbers go in what spot. P hat is given to us, 0.669, N is given to us, 124. Z star we have to find. So I drew a little picture here, 99% confidence interval. So in the middle is 99%. So that means 1% is in both tails. So I have to take that 1% and divide it in half. So it's really a 0.5% and a 0.5%. Percent meaning move the decimal over 2 spots. So that's why I go inverse norm of 0.005. And that will give me the negative 2.576. So that's where the Z star is coming from. I know the other one will be the positive. So really I only have to do one of them to get my Z star score. So now it's just a matter of plugging it in. p hat, plus or minus z star, square root, p hat, 1 minus p hat. So again, these two numbers right here must add up to 1. That's where the 0.331 is coming from, divided by the sample size. Just to show you in my calculator how I'm getting this margin of error, I took 0.669 times 0.331. That's what this little answer part here is. Divided by 124. That's where this 0.00178 is coming from. But I have to square root it and then multiply it by the z star score, and that gives me my margin of error. Pretty big margin of error, almost 11% margin of error. Part of that is due to a very small sample size. So 0.669 plus or minus 0.109. When I subtract it, I get 0.56. When I add it, I get 0.778. So wow, from basically 56% to almost 78% is our confidence interval. That's a big confidence interval. So we just need to do one last thing, and that is the conclude. So I'm going to give you about a 30-second head start and write that last sentence. So, hopefully your sentence looks something like this. We are 99% confident that the interval from 0.560 to 0.788 captures the true proportion of couples who tilt their head to the right when kissing. Okay, threw it in there. Oh, my goodness, we've talked about sex today, we've talked about kissing. Oh my goodness. What's going to be next in these examples today? Oh, hugging? We leave that to Mr. Joachim. So, we got one more concept to talk about today, and then we are finished for the notes today. Woohoo! So, now, one of the things, okay, that we and companies want to try to control is this margin of error. I'm just going to flip back to this last problem, because in this last problem, notice how here the margin of error was almost 11%. Being off by 11% in either direction, that's pretty big, right? So sometimes companies want to find ways to reduce this margin of error. They want it to be only like 5% or 4%. If you're collecting a poll on who's going to be the next president of the United States, do you really want that poll to have a margin of error of 11%? Probably not going to tell you a whole heck of a lot. So we want to figure out what or ways we can reduce it. Well, if we think about the formula, I'm going to go back to the formula up here. There's really only 3 variables involved. P hat is one of them. Well, that's the sample proportion. That we really can't control, because we're just going to collect the opinions and we don't control the opinions of others. Right? Z star, we do have some control of. But if we think about Z star and how that works, it's based on your confidence level. Okay? So, you know, this one was a 99% confidence interval. It's going to be a big interval. Okay? But if we want to shrink that interval down, shrinking the margin of error, then our confidence level goes down. So we're not going to capture, you know, the true mean with many, many confidence intervals as often. So that's the downside of changing the percentage. The last of the 3 variables that are there is n, sample size. How many people we actually go out and ask, we can control. And what we see is, boy, since we're dividing by n, this value, since we're dividing, if we increase it, if we divide, it's actually going to cause it to become a smaller and smaller and smaller value. So larger sample sizes give us a smaller margin of error, give us more accurate results. Okay? However, going to ask tens and hundreds of thousands of people, not so fun. So, if we go back to this page here, when we talk about the margin of error, that's the plus minus part. Now, when we're going to use the margin of error, and we want to figure out a sample size, okay, to guarantee a margin of error to be less than some value, we don't know what the true sample proportion is. In fact, we don't know until we actually collect it. So the question is, what do we use for p hat? So since we actually don't know that until we collect the sample, okay, what we substitute in for p hat is 0.5. This is because 0.5 will actually produce the largest margin of error. So if we can do it for 0.5, we've guaranteed all the ones that are different than 0.5 will be less than it. So we'll guarantee that it will work for all of them. So basically what you're going to do is you're going to take the margin of error formula and set it less than or equal to the desired margin of error that you want. So to demonstrate, a couple last problems for us today. If you look at the first question here, it says, suppose you wanted to estimate P, the true proportion of students at your school who have a tattoo. Whoa. Wow. Sex, kissing, and now tattoos. What in the world is this class coming to? With a 95% confidence and a margin of error of no more than 10%. Okay? So, it says determine how many students. So, since how many students is what I'm determining on these problems, I'm trying to find n. Should be surveyed to estimate P within 10% with 95% confidence. So what I'm doing is taking the confidence interval formula and setting it less than or equal to my margin of error. Now I need to plug in the values. Z star. Well, Z star again is determined by the confidence interval or level. 95%. Did we already find that Z star score?
Yes.
Yeah, we did it on the first one. So for our time save, looking back at our first problem, we know that 95% corresponds to a Z score of 1.960.
Isn't it plus or minus?
Right, but since we're talking a margin of error and I'm going to have it be within a positive, I just have to worry about the positive and know that it's going to be within that. Okay. So for my p hat, always we put 0.5. This will guarantee the biggest margin of error. N is what I'm looking for. I want that margin of error to be less than or equal to 0.10. I want to be within 10%. So now it's time to do some calculations. So I'm actually going to bring my calculator over here in the corner. What should I do first on this problem?
Divide out 1 point.
Yeah, divide both sides. Let's get rid of the multiplication and divide both sides by 1.960. In fact, I'm going to do 2 steps. Because once I divide that out, I could actually multiply those two together. So 0.25 over n is less than or equal to, on my calculator, 0.10 divided by 1.96. So 0.051 ... And I'm going to put ... because it's in my calculator, and I'm going to keep it in my calculator all the way through the problem. So, what do I get rid of next? Yeah, square root and square. So I gotta square both sides. So 0.25 over n is less than or equal to. So I just go back to my calculator. I have it in there. So all I have to do is raise it to the second power. So I just need to square that answer. All of a sudden it's 0.0026. 26 ... So what variable am I solving for? N. Where's n located? In the denominator. So let's get it out of there by multiplying both sides by n. So 0.25 is less than or equal to 0.0026 ... times n. So if I want n by itself now, what do I need to do? Divide by this, yeah, this 0.0026 ... So now I'm going to flip the whole statement. So n is actually greater than or equal to, because I'm reading it backwards. Then I need to plug this in my calculator. So 0.25 divided by this 0.0026 is my answer. And I get 96.04. So n has to be greater than 96.04. So how many students do I actually have to survey?
What's your problem?
Yes, 97. Because you actually have to go to the next number above it. It has to be greater than 96.04. 96 is not greater than 96.04. Alright. I want you right now to try letter B. Follow the same process. The numbers will be slightly different.
Just go up just a little bit. Thank you.
As you finish up, check your answers up here and see if you got that you needed to survey at least 664 students. That's a lot of students. Okay. So just to take you through the problem real quick, okay. The first setup is here in pink. 2.576 is because it's a 99% confidence interval. That's the z-score. The p-hats are always 0.5. Our margin of error wants to be within 5%. So now, first thing I did was divided by 2.576. When I did, on my calculator, I got this 0.01. You can actually still see it there, 0.0194. To get rid of the square root, I squared both sides. So then all of a sudden you can see here in green I get this 0.000376. Notice how here it says e to the negative 4 on my calculator? That means I have to move this decimal over 4 spots, hence the 3 zeros. So then I multiply both sides by n, so it clears out the n out of the denominator. So now I have n over here on the right side, so I need to divide by this decimal that's in my calculator. So I'm going 0.25 divided by my answer, and I'm getting 663.5776. So I round up because it's got to be greater than that. So that's why we're interviewing 664 people. Wow, just for a margin of error of 5%. So when you see those polls done on CNN or done by Gallup, okay, or done by other organizations, they have margins of errors of like 3%. Just to let you know, they tend to go out and survey over 1,000 people. They do that because they want that margin of error to be a lot smaller. Think about trying to survey 1,000 people, how long that might take. They say the success rate of getting a successful person to respond, especially by phone these days, is less than 10%. They have to contact over 10,000 people just to get 1,000 people to actually respond. Crazy.